Now the another way to change that default behavior is that we can have what we call a parameter that receives an arbitrary number of arguments. Okay, so this is a parameter. If we just put the parameter name and precede it with a star, it will take any number of arguments and collect them all in one tuple. So this is the parameter. The value that we sent, the arguments that we sent, are arbitrary number of values. Okay, and that will collect all this number of values into one parameter that is a tuple. Okay, so let's say if we wanted to calculate the sum instead of just add 2, we can define it this way, and we'll loop over the tuple to calculate the sum. So let's try this out here. I'm gonna comment this out. So let's say I'm gonna define a function, so def sum, and this function can take any number of arguments. So I'm gonna say values, and then this is just a parameter name. If I leave it like this, it expects one value. So if I don't, then I want multiple values to be possibly entered here. So I can I add the star, and then this way, if we want, we can print values just to see how they look like. And then I know this is gonna be a tuple. We can examine it as well when we run it. So I can loop over it for v in values. Now I want to calculate the sum, so I'll prepare a variable that is neutral to the add. So it starts with 0. And then I would say total plus equal v. And then I just return total. And then when I call this function, I can call it. So the result, I can call it with any number of values. So sum, I can say 4, 5, 6, 7, or so print result. Or I can send more or less, okay, any number of arguments. So let's say I'm just gonna send 4, 2, okay, more or less, it doesn't matter. Okay, so let's have a look inside this function. So now we are about to execute this function. I'm gonna step inside. Now see how what values is. It looks like a tuple. I can also examine that. So I can print the type. I'll call the function types on values to see what is a type, and it says it's a tuple. Okay, and then we can, so we just loop over the values to calculate the sum. So that's all what I wanted. I don't want to keep examining the function. I'm gonna step outside. Now this will print the result, and then let's step inside again. See, now we have a tuple out of 2, and it will calculate the values as expected. So any number of arguments can be sent, and at the end it will collect them all into a tuple. All right, so that is the arbitrary number of arguments. Now, if you remember when we said when we're describing a syntax, the description of the syntax, the square brackets in the description of the syntax mean that it's optional. So we can, these parts are optional here. Okay, an example of that we have seen, we've been using the print function in order to print something, but we only used a version of the print function that takes one value. So we've been using only one value, or we've been sending one value that is a concatenated string. Now we don't have to do that. because the print function has an arbitrary number of arguments, a parameter gets receive arbitrary number of arguments. We can send any number of arguments here of any type, and we don't have to worry about converting them to a string, because internally it will manage how to concatenate them. So by default, it can take all these values, turn them into strings and concatenate them separated by space. All right. Now, usually they should come at the end, but it is possible that we bypass that. So this is how it normally, I mean, usually people put the positional parameters first, okay, and then the arbitrary number of arguments at the end, but it's possible to bypass that. Okay, so now if we do this, the first value go to the first parameter, second, and then the rest will be connected into that tuple. But we can bypass that if we used the keyword. All right, so we can put the arbitrary arguments in the first, like at the beginning, and then we can define another parameter here, but later on when we try to call it, we will have to use the keyword, I mean the parameter name as a keyword. Okay, otherwise it wouldn't know when to stop. Okay, when to stop collecting the values. Okay, so we can try this out here. So let's say here we're gonna send header and footer. Okay, so in that case, I can send the header and footer at beginning and end here. So let me just comment these out. So calculating. And then the second is say done. Okay. So that shouldn't be a problem because the positional arguments would go first. Okay, so that shouldn't be a problem if I step inside. Now the header will be taking the first value, this footer will be taking the second value. Okay. And then the rest are collected into the tuple. Now, if I happen to change this order, and I just change the order of the values as well, okay, that's not sufficient. Just trying to change the order like this is not going to be sufficient because if I'm going to try to step, it will give me an error because the two positional parameters, I mean the two values, it doesn't know when to stop collecting into the tuple. All right, so I have to use the name of the parameter as a keyword here, so that we let it know that these are going to these parameters, and then the rest are collected into the tuple. All right. Okay. Let me see. All right, so that is how we use the arbitrary parameters with, like, we mix the arbitrary number of arguments with the positional arguments. Okay, now it might worth mentioning that it is possible that we have a tuple or a set of values that is, I mean, it is possible that we send a no value for the arbitrary number of arguments. So if I do like this, comment this one part out. So here, if I try to send no value here, it will take it, no problem. And it will print 0. Okay, so 0, no value. I mean, the arbitrary number of arguments include 0 number of arguments. All right.